We have a longer section today, lesson 82, and there's a lot in here. So if you have your unit circle available, you'd want to take that out, or I believe it's on page 448, and let me confirm that. The unit circle, that is. 400, I want to confirm that because I just threw out that number. Yes, so the unit circle is on page 448, or I did post a completed unit circle and you can use that. And it was probably, I posted it for that section, whatever lesson that was in 448, there should be a unit circle posted, or you can pull one off the internet. So we're going to be graphing sine and cosine functions, and they put a lot of information in this section, but it is important as you move forward to maybe possibly the next math class. So sine and cosine are called periodic functions, and that's a function that repeats exactly in regular intervals. And so the graph looks like a pattern because it keeps repeating itself. So we're going to start with sine function, and I put a little review here. The sine of theta is the y value on our unit circle. So if you look at the unit circle, I have my quadrantal angles. So this is 1, 0, this is 0, 1, this here is -1, 0, and down here is 0, -1. Now each of these has a value for your degrees. So for example, here would be 0 degrees. Over here is 90 degrees. 180 degrees, 270 degrees, 360 degrees, and then I could keep going. 450, 540. I just keep adding 90 degrees as I go around. So I'm focusing on the y value. So the value of sine at 0 degrees is 0. The value of sine at 90 degrees is 1. The value of sine at 180 degrees is 0. The value of sine at 270 is -1. The value of sine at 360 is 0. And so these values would keep repeating themselves. That is why it's a periodic function. So I want to show you what the graph looks like. It's going to have many parts. It's also in the book, but I will go over each part for you. All right, so I've got my y axis is going to show the radius of +1 and -1 on our unit circle because there's our y value. But our x-axis is either in degrees or radians. So I'm going to do every box is 45 degrees. So 45, 90, 180, 270, 360, and so on. Okay, so 360 plus, and that's 450. And it would be negative degrees to the left. So -90, -180, -270. Now each of these has an equivalent value in radians. So on the unit circle, 90 is the same as pi over 2. 180 is pi. 270 is 3 times pi over 2. 360 is 2 pi. This would be, is it 4 pi over 3? Of course, I didn't write that one down. Hold on, sorry. 450 over, hold on, over 360. I'm having to divide. 5 pi over that's not right. anyways, it all has, sorry, I can't convert it on the spot. Negative 90 would be negative pi over 2. This would be negative pi. This would be negative 3 pi over 2. So I'm going to graph this according to our points over here. So when I am at 0 degrees, y is 0. So 0, 0. When I'm at 90 degrees, sine is 1. So at 90 degrees, 1. When I'm at 180, it's 0 again. 270, I'm at negative 1. 360, I'm back at 0. 450, I'm back at 1. And so here this graph should be very smooth, almost like the waves of an ocean, or the ocean, I don't know why I said ocean. Okay, and to the left, it's going to look in reverse. So if I go clockwise, this would give me negative 1, then 0, then 1. I'm just looking at the y values, remember? And I get this repeated wave that goes through our graph. Now I'm going to highlight the parts so that you can see them. So here we go. I have from here, so I'm going to start with amplitude. The distance from the middle to the top of our peak and the middle down is called, I'm just going to put an A here, is called our amplitude. Okay, so the height from the middle to a peak or the middle to the valley is called our amplitude. And so in this case, our amplitude is 1. You can also think of it as radius. Our amplitude is 1. Period refers to how long it takes to complete a full cycle. And so, for example, a full cycle would be 1 peak and 1 valley. And so a full cycle should take 360 degrees, and we call that period. A full cycle, it should have, it would also in radians be 2 pi. 1 full cycle, and I'm going to write that below. A period is the length of 1 full cycle in degrees or radians. And by full cycle, I mean 1 peak, 1, oops, I spelled peak wrong. 1 peak, 1 valley. And a period can also be measured from peak to peak, and it's still 360. It's just how you'd prefer to label it. So, something to notice though is that sine does begin at 0, 0, because when at 0 degrees, y is also 0. So this is our sine function. Now we're going to talk about our cosine function. Now cosine is the x value on your unit circle. And so I'm going to, again, pop up those 4 points. I have 1, 0, 0, 1, negative 1, 0, 0, negative 1. Each of these has a degree value, so this is at 0 degrees or 360. This is 90 degrees, 180 degrees, 270 degrees. And this time I'm focusing on the x value. So the cosine of 0 degrees is 1. The cosine of 90 degrees is 0. The cosine of 180 is negative 1. And the cosine of 270 is 0. The cosine of 360 is 1. The cosine of 450 is 0. And it just keeps repeating 1, 0, negative 1, 0, 1, 0, negative 1. And it keeps repeating. That's why it's called a periodic function. And so there is a slight difference, though, between sine and cosine because their values are different. So our graph looks very similar, but the difference is our starting point. So let's say we've got 90, 180, 270, 360. And then this way would be negative 90, negative 180, negative 270, sorry. And I've got 1, negative 1. So at 0 degrees, cosine is 1. At 90 degrees, cosine is 0. At 180, it's negative 1. At 270, it's 0. At 360, it's back up at 1. And so this one has the same look. It looks like waves of an ocean, but the difference is that sine starts at 0, 0, and cosine starts at 0, 1. If I go in reverse, negative 90 degrees, right, that's negative 1. Negative 180 would be, did I do that wrong? Sorry, I did do that wrong. Negative 90 is at 0. Negative 180 is at negative 1. Negative 270 is at 0. And so we see the same pattern on the left. Now, each of these does have, like this is pi over 2, pi, 3 pi over 2, 2 pi. This would be negative pi over 2, negative pi, negative. Each of these has the same in degrees as it is in radians. Now, a couple things are very similar. Our amplitude is still 1. Just like it did for sine. Sorry, I misspelled right here. And our period is the same from peak to peak. That is still 360 degrees. So you can measure it from peak to peak or from the center, one peak, one valley. So you do one of each. So there's 2 ways to measure it. Now, these are the basic functions. I'm going to get into the formula. So here is the form that it should be in. So y equals a times the sine of bx, or this looks the same for cosine. Y equals a times the cosine of bx. Okay, so there's an invisible multiplication there. Now, A is our amplitude. Okay, so that is how high or the peak or valleys are going to be. If A is a negative number, then it has been a reflection. B represents B is our number of cycles in 360 degrees or 2 pi. So A is our amplitude. B is the number of cycles in 360 degrees. So we're actually going to now jump into our lesson practice, which is on page 583. And we're going to start with part A, where it says y equals negative 2 sine of 4x. And it is asking us to, you can use the graph or just the equation to identify amplitude and period. So I should have written on this prior sheet that period is 2 pi divided by b, or you can use 360 divided by b. Okay? A is our amplitude. Period is 2 pi divided by whatever b is, or 360 divided by b. So here is our formula. I know this is A and this is B. So my amplitude is 2 because that's what A is. But our period is 360 divided by B, which in this case is 4. So that gives me 90 degrees. So the 4 means that there are 4 full cycles in 360 degrees. We just found that that means that each period is 90. So there is a full cycle for this graph every 90 degrees. Okay. This can also, or you could write 2 pi divided by 4, which would give us 1/2 pi, or pi over 2. So either of these is acceptable for period, and here is your amplitude. So let's try part B. The graph is, or the equation, sorry, is y equals 5 times the cosine of 1/2 x. So let's identify our A term, that's A, and this right here is B. So I can say that my amplitude is 5, and then I'm going to find my period. So this is saying that there's half of a full cycle in 360 degrees. Okay, so there's only half of, that's what that 1/2 is saying. So we're going to find out how many degrees it takes to complete a full cycle. So remember, our period is either 360 divided by b, which this would give me 720 degrees, or it's 2 pi divided by b, which 2 divided by 1/2 is 4 pi. So our period is 720 degrees, or 4 pi. So there's our period, there's our amplitude. All right, so for this next part, they'd like us to physically graph. And so I'm going to do it by hand. I'm sure you could use Desmos, but I'm going to show you how to do it by hand. So we are going to graph y equals 4 times the sine of 2x. So I know that my amplitude is 4, and period, right, I know this is B, and this is A. So my period is 360 divided by B, which is 2. So I should have a full period in 180 degrees, or I could use 2 pi divided by 2, so in pi. It's in radians or degrees. So I'm going to go ahead and graph this. My x-axis should go right in the middle. My amplitude is 4. So I'm going to go by 2. So 2, 4, 2, 4. And then I have, this is 90, 180, 270, 360, negative 90, negative 180, negative 270. Okay, so I know that sine starts at 0, 0. And I need a full cycle in 180 degrees. So I need a peak and a valley by the time I hit 180. So I have to evenly space it out. Because they're saying that I should have, the 2 means that you should have 2 full cycles by the time you get to 360. So there's 360. 2 full cycles would be 2 peaks and 2 valleys. So there's 1 cycle. Watch, 1 goes from here to here. There's 1. And then from here to here is 2. So I have 2 full cycles. So then in the reverse, I'm going to make the same pattern. I have 1 full cycle, and there we go. Now you can confirm that graph using Desmos. Part D, y equals -3 times the sine of 1/4 x. So my amplitude is 3. I have a reflection because it's negative. And then my period is 2 pi divided by 1/4, which gives me 8 pi. So I'm going to use radians for this one just so you see one of each. And anytime I have a reflection, I'm going to use my pencil to assist. So here we go. So I'm going to make each box worth pi. 2 pi, 4 pi, 6 pi, 8 pi. And I know that my amplitude is 3, so there's 3, there's -3. Okay, and I know it's a reflection, so I'm going to use my pencil. I should start at 0, 0, and I need a full cycle before I get to 8 pi. So I'm going to say it needs to go, here's one mountain, and here's one valley. That would be a full cycle from the center here, and then it would repeat here. But it's been reflected, so I'm going to flip these points. So this point up here goes down here. This point stays. This point is reflected up here. This point stays. This point is reflected up, and then I'm going to connect. And there is my graph. We're going to do 2 more, and then we're going to move on. I'm not going to do part G. Or no, I will do G. All right, so let's move on to E. We're going to graph y equals 3 cosine 2x. So there is A. So my amplitude is 3. And that is B. So my period is, you could do 2 pi divided by B. So my period is pi. So I need a full cycle in pi radians, or 360 divided by 2 is 180. These have the same value. Okay, so here we go. So just depends on how you want to do this. Let's say this is 90, 180, 270, 360, -90, -180, -270. My amplitude is 3. So cosine starts at 0, 1. And this is saying I need a full cycle, so peak to peak in 180 degrees. And so I'm going to, they have to be evenly spaced, so it should look like this. That would be one full cycle, peak to peak. So then you're spacing it out every box. So you go like 0, 1, so 0, 3, and this would be at 0, this would be at -3, back to 0, back to 3. It's the same pattern as the others. Next one, y equals -3 cosine 1/4 x. So in this case, my amplitude is still 3, but there's been a reflection because it's negative. My period is 2 pi divided by 1/4, which is 8 pi. So it's going to take 8 pi for a full cycle to occur. And I have a reflection. So we got a lot going on. I have amplitude at 3, -3, and I'm going to do 2 pi, 4 pi, 6 pi, 8 pi, or -2 radians, -4 radians. It's however you want to call it. So I'm going to use my pencil. I need a full cycle to occur here. That's 8 spaces, so I'm going to guess 1, 2, yeah. Boom, boom, boom. So every 2 boxes. So one full cycle would be like this. But our points have been reflected. So I have to reflect this point up. This stays. This point is reflected down. Stays. This point's reflected up. Stays. This point is reflected down. And so there is my graph. Finally, G. So G says write an equation for signal T. So first we need to find the amplitude and our period. So using the book, I don't want to knock, sorry, I have water right here. My amplitude, the peak hits at 2, so my amplitude is 2, and a full cycle from peak to peak is in 2 pi. So my period was 2 pi, my amplitude is 2. So when I go to write this equation, oh, also the starting point is at 0, 1, so I know this is cosine. So to write my period, it would be 2 pi, this is B, right, and this is A. So 2 pi divided by 2 pi is 1. So my graph is y equals 2 cosine x. For your homework, you're going to skip numbers 12, 13, 19, 20, 27, and 29. Thank you.